So we've created a data frame in decimal degrees and used, so we've created a data frame and it's in decimal degrees, and we brought in a background file in order to situate ourselves and use the drawing tools to create a bounding box or an area of interest for the Malibu area, and used this data frame in decimal degrees to identify the lower left and upper right corners of this bounding box. We are going to use this AOI that we've identified online to download data from the National Map Viewer. So the next step in the lab is to go to the 3D elevation program on the web. So open up a browser and you can either link to this site, or if you open up a browser, and Google 3D elevation program, that will take you to the website. Now, every time I go to this website, it's the United States Geological Survey, it looks a little bit different. But we are going to go to the 3D elevation program. I encourage you to read about the data, metadata, but for the purposes of getting to the point here, we're going to go to download data and visualization. So I'm going to click on access data. And it's going to take me to the data download application, which I'm going to launch. And I'm going to click this radio box, make AOI from coordinates. And this will allow us to enter in the coordinates that we just recorded from our bounding box. Again, it's really good GIS etiquette, geospatial etiquette, to have that bounding box accessible so that every time you go to collect data for a particular study area, you're consistent in the boundaries. So I'm going to click coordinates, and it opens up create box from coordinates. And this is why we needed our data in decimal degrees. So the minimum longitude that I recorded is minus 118.95. It's minus because we are in the Western Hemisphere, and it's important to have that minus sign in there. My minimum, or my lower left latitude, is 33.996. Again, I got that from the MXD. The upper right corner that I recorded is minus 118.562. And the upper right coordinate in, I made a mistake, Control C. My longitude is 118, and my maximum latitude is 34.113. So my latitude are the 34s or the 33s, and my longitude is minus 118. So I have my bounding, the corners that I got from my bounding box in ArcGIS, and I'm going to select Draw AOI, and it draws the AOI, or the area of interest, for that bounding box that we created in ArcGIS. Now, there's a lot of data that you can download from this site. It's amazing, and I encourage you to come back and repeat this download for different data sets. But right now, we're going to focus on the 3D elevation products, and I want you to get a 1/3 arcsecond digital elevation model. If I wanted to say show availability, it shows that there's data available for this whole area at 1/3 arcsecond, and I'm going to hide that. Maybe I want a 1 meter DEM. I'm clicking Show Availability to see if there's a 1 meter DEM. That means each grid cell is 1 meter resolution. And it actually shows that there are data in 1 meter resolution for this study area. A 1 arcsecond is a much larger area. Let's see what it says for 5 meter DEM availability. In the lab, I have you download a 1/3 arcsecond for a study area. If you are able to get higher resolution, 1/3 arcsecond, recall, is 10 meter grid cell resolution. There is no 5 meter available. So we're going to just take the 1/3 arcsecond, and I'm going to select Find Products, and it's going to pull out the area. And it gives me 2 data sets that I can choose from. Both of them are GeoTIFFs, which are georeferenced TIFF files. And it gives me the entire 1 degree area. So 1 arcsecond, 1 by 1 arcsecond degree area. I'm going to select the file that's bigger. It's 1/3 arcsecond. It was from September 2019, and the metadata was updated in March, so quite recently. I don't really know what the difference is between these. I think this one is more zoomed in perhaps to where Catalina is. But I'm going to select the first one, which is what I instructed you to do in the lab document, and I'm going to select Download. And you see when you select download, it's being downloaded right here to your download folder. It saves it right here. And if I go to show in folder, it will show me I actually had downloaded one previously. It shows me the TIFF file has been downloaded, 447,000 kilobytes. So you want to take this and you want to copy it from your download folder into the folder where you have saved the lab files. And I will see you back in the next video where we will access this TIFF file. So when you find your data, download it and copy it from your download folder to your student folder or to the folder for the lab. I'm going to copy this and I will see you in the next video.